Hello guys, welcome back to another video. So today we are going to talk about nuclear bombs, nuclear energy, and how do nuclear reactions work. We are also going to talk about nuclear fissions. This is just the part 1 of a series, nuclear reactions. The second part will be about nuclear fusion, hydrogen bombs, and nuclear power plants. So let's get started. August 6th, 1945. A bomb named Little Boy is dropped on the city of Hiroshima in Japan. 3 days later, a bomb named Fat Man is dropped on the city of Nagasaki. Both of these bombs combined together caused the lives of 1.5 lakh to 2.5 lakh people. They were truly destructive in nature. And before this bombs had been deployed, Einstein had even written a letter to the President of the United States that nuclear bombs are truly destructive. But it went all into vain and we had this incident. But hopefully this is the only recorded incident in the history of mankind where nuclear weapons have been used. They are truly destructive. Now we come to the topic of how do these weapons work? What do they look like? How can they destroy two whole cities? So mostly if you ask people that what do they imagine if we think about a nuclear weapon, they think if it is something really big which is caused such a big destruction. But in actual size, the nuclear bombs and the simple torpedoes and other bombs, in size they are no different. But it is this special thing in nuclear bombs, that is nuclear reactions, which allows them to have so much energy. So in the bomb, the Little Boy that was dropped on Hiroshima, only 700 to 600 milligrams of uranium was actually converted into energy. All the other uranium was just left there. Only 700 to 600 grams, and that caused a whole city to blow up. That is just terrifying. And that is why there are many organizations in the world which are trying to stop nuclear warfare. Currently there are only 9 countries in the world which own nuclear weapons. So now let's think about how do these bombs work. So let's start with the materials. Normally the materials which are used are either uranium-235 or plutonium-239. Let's talk about uranium-235 first because it is more common. So uranium-235 and plutonium-239, both of them are unstable, highly unstable and radioactive. Unstable means that after some time their nucleus splits up, it divides into 2 other atoms, namely barium and krypton, and also releases 3 more neutrons, plus a lot of energy and radiation. So this is why they are highly unstable. But what is radioactivity? See, radioactive means something which releases ionizing radiation. Even sound and light are a type of radiation, but they are not ionizing radiation, and we are specifically talking about ionizing radiation here. Ionizing radiation is of 3 types. Those 3 types are alpha, beta and gamma. So alpha, beta and gamma alpha is the weakest and gamma is one of the strongest ones. Alpha is just the nucleus of helium-4 atom, or 2 neutrons and 2 protons clumped up together. If you are wearing some clothing and your whole body is covered including your face, then you will be shielded from alpha radiation. And if you're sitting in your house, then beta radiation won't do much. But what about gamma radiation? Here lies the problem. It is made up of purely energy, whereas beta radiation are just electron-like particles, so they can be stopped by the walls of your house. But gamma radiation, we require thick walls of lead or concrete to stop it. Otherwise, it will spread and it causes many diseases like radiation sickness and cancer. So let's cut to the chase. how do these bombs work? What are their plans? So normally, if you fire a neutron towards the nucleus of uranium-235, it decays down. It splits up into barium, krypton, and 3 other neutrons. So to do this, we don't have any kind of neutron guns. We have 2 other mechanisms. The first one is known as the gun mechanism, in which we take half of the uranium here and half of the uranium on the other end. We join them through a hollow tunnel, and behind this uranium we have some explosive. So when we deploy the explosives, this uranium moves towards this uranium, and they both collide, pressurize, and start a chain reaction. That is, when one nucleus of uranium splits, 3 neutrons are released, and they cause other nucleus of other 3 uranium to split, and this is how the chain reaction goes on. All this happens very fast, in just seconds, and your bomb has already destroyed a whole city. That is the destructive power of the atom. So the second method, in which we take the fuel in the center, like in the shape of a ball, and we surround it by explosives by making a complete perfectly made circle of explosives. So when these explosives are deployed, they cause immense pressure and cause the uranium to be compressed, and that again starts a nuclear chain reaction. But now, how can just some milligrams, some 600 to 700 milligrams, cause the destruction of a whole city? Well, to clarify that, we have the equation E is equal to mc square. Here E stands for energy, m stands for mass, and c stands for speed of causality or speed of light in a vacuum, which is approximately 3 into 10 to the power 8 meters per second. And we are squaring that number, remember? So 9 into 10 to the power 16, well, that is a big number. And even if we multiply just a little bit of mass with it, only if a little bit of mass is converted truly into energy, still we get a lot of energy. Which means that Einstein, who gave this equation, gave us a way of thinking matter and mass in another way. We first thought of matter, mass, and energy as different quantities, but no, they are just the same identity. Actually, everything that surrounds us and everything that is around us is energy. What we think of as matter or mass is just the compressed form of energy, and if we decompress it or if we expand that mass, then it creates energy, and that is what these nuclear bombs do. So because of the truly destructive nature, people around the world are trying to stop it. But there's a good side to this also. Why? Because we also have nuclear power plants, and I think that this was the true thinking of Einstein when he created this equation. When he discovered this equation, he was surely thinking about the nuclear energy and not the bombs. So that is it for today. In the next video, I'll be talking about hydrogen bombs, nuclear fusion, and nuclear power plants. Till then, share this knowledge of Vyomkaal with all your friends so that they come to know more about space-time. And comment, like, and subscribe. Thanks for watching. I'll see you next time. Bye.